when we went through the rules, there were two of the rules that we didn't really talk about, and it talked about fractions and denominators. Remember, a fraction is just a way to show division. When I create the fraction 1/2, that means I took one thing and I divided it into two parts. So we're going to take a look at those, the properties of radicals, the things that we learned yesterday with simplifying, and then how to make them work within a division problem or within a fraction. So remember from yesterday, we can't have decimal answers, so you're not going to grab your calculator and type in square root of 2/9 to give me an answer. That's how we'll check things. We still today will not be able to have pairs of factors. So if you have square root of 12, even though 12 is not a perfect square, you have to break that down because it does have a pair of 2's in there from a 4 times 3. So we always want to make sure we're finding those pairs of factors. And this time, there cannot be a fraction in the radical. So when we look at number 1 and take a look at number 2, that's a huge error that we have there. And then the fourth rule, it says no radical in the denominator. So I can't have a square root. I can't have a fraction that has a square root in the numerator and a square root in the denominator. So what we're going to use is this idea that if I do have the square root of a fraction, I can break that up into two separate radicals. And so that way I can simplify A, I can simplify that square root of A, and I can simplify that square root of B. When you're presented with a fraction, when you're presented with division, there's going to be 3 questions that you ask yourself. And those 3 questions will lead you to which method you want to do. Now I will tell you guys the order that you ask yourself those questions is pretty important. So I call this method 1. This is actually question number 1 that you need to ask yourself. When you're looking at these problems, you need to ask, is my denominator a perfect square? So let's take a look at the first problem. We have the square root of 2/9. Is my denominator of 9 a perfect square? Yeah. So if it is, I'm going to split up the numerator and denominator. So I'm going to rewrite this as the square root of 2 over the square root of 9. Now my rule is still in violation. This time I'm not violating rule number 3 because I don't have a fraction under the radical. I have 2 under the radical and I have 9 under the radical. But the rule I'm violating is the 4th one. I can't have a radical in my denominator, but it's okay because 9 is a perfect square, right guys? What is the square root of 9? 3. So I'm going to simplify that perfect square and call it a 3. I'm then going to go to my numerator because there's no rule about radicals in the numerator. The only thing I have to worry about is square root of 2 simplified. And can that 2 simplify? Can we break down 2? No, not at all. 2 is prime. So ladies and gentlemen, this is what your answer is going to look like today. Square root of 2 all over 3. I have a fraction, and it's okay to have a fraction. It's okay to still have that division, but I have to make sure that what's under the radical is a whole number, 2 is a whole number, and I need to make sure that denominator is also a whole number. I have just a 3 there, no radical, so we're good. So if you look at number 2, the first question we're going to ask ourselves is 121 a perfect square? If you're not sure, grab your calculator. The square root of 121. But I heard someone say yes, so we're going to split that up into the square root of 120 over the square root of 121. Now, what is the square root of 121? 11. So I'm good. My rules are all good. No fraction underneath the radical and no radical in my denominator. But I've got to check the square root of 120. Could 120 simplify? Well, I'm guessing a number as big as 120 it's going to, right, guys? So you can work it out here. I'm going to go and work it out kind of off to the side here and down low. What do I want to break 120 into? 10 and 12. I like that. And I'm going to do 5 and 2, and then I'm going to do 2 and 6 just to get a pair of 2's right away. That's one thing that I usually do is that I know I can make a pair. I make it as soon as possible. So you could have written 12 as 4 times 3, and that would have been fine. But I made my pair of 2's right there. 6 is 2 times 3. Because I've already paired those 2's together, I know this 2 is a singleton. So when I take a look at what I have left, this 2 is going to be outside the radical because that's my pair of factors. And then 5 times 2 times 3 should look familiar because I think we did that in the warm-up. Should give me square root of 30. Now the only thing you have to be aware of, guys, is that this is a division problem. So once you have 2 and 11, once you have numbers outside the radical, you need to try and divide those. Does 2 divided by 11 simplify? Does the fraction 2/11 simplify? If you're not sure, grab your calculator, type 2 divided by 11, and turn it back into a fraction. But because 2 and 11 don't have a common factor, 2 doesn't divide into 11, I know that that fraction doesn't simplify. But you're going to check and see, do these numbers outside the radical simplify? And because 2 and 11 don't, there is our final answer. Today's notes are a little bit different than yesterday's, guys. We're going to do an on your own after every question. So I do believe the next 2 problems are on your own. So I want you guys to try A and B. Remember, that first question is my denominator a perfect square? So let's go. Ladies and gentlemen, I'm afraid we may have made these ones just a little bit too easy. Because does 5 simplify at all when we're looking at the square root of 5? No, it's prime, but the square root of 49 is 7. So your first one should have been square root of 5 all over 7. We okay there? And then for B, 25 is a perfect square. So I'm going to break that into the square root of 3 over the square root of 25. Once again, 3 is prime, so I know that that's going to stay the square root of 3, but 25 is that perfect square, so we should have had square root of 3 over 5. I'm hoping you guys got those 2 right this close to the examples. Am I correct? All right. Here we go. All right, once again, it says method number 2, really question number 2. So the first thing we're going to check and see, is my denominator a perfect square? Is the square root of 11 a perfect square? No. The next question we're going to ask ourselves is, can I divide the numerator by the denominator? That's the question I want to ask. So can I divide 22 by 11? Yeah. So when I do that, I'm going to actually do that division, 22 divided by 11. So I'm actually kind of going in the reverse order of what we did in method number 1. I don't have a fraction under the radical. I've got 2 separate radicals, but because they can actually divide each other out, I'm going to make it one fraction. What is 22 divided by 11? 2. I still have the square root because all you've done is divide, and so we have square root of 2. This looks like the problems that we gave you yesterday. It looks like the problems in the warm-up, so you need to check and see, does the square root of 2 simplify? Nope, 2 is prime, so we are done. All right. Is 6 a perfect square? No. Does 6 divide into 48 though? Yeah, so I want to do that division. Now guys, I rewrote it as a fraction. If they're both radicals, I'm hoping you guys know that you can divide those like terms, just like we multiplied those radicals yesterday. So if you just want to do that division right away and call it square root of 8, I am fine with that. But then keep in mind, you have to check and see, does 8 simplify? Is 8 prime? No. If the number isn't prime, guys, then I highly recommend right now making that factor tree. This is 2 times 4, and 4 is that perfect square. It's going to give us a pair of 2s. And so our final answer, I'm running out of board space, should be 2 square root of 2. All right, are there 2 on your own again, guys? I think they're on the back side this time, though. So let's turn the page, and let's do, I'm going to guess this is C and D. Oh, so predictable. Go.
These two, it's done. So these two are like, right? Turn on the outside. And then turn on the outside. And then the three goes together, right?
Oh, it was
one pair comes out.
one pair comes out as a single case, or a single three, whatever it is. All right, ladies and gentlemen, is 3 a perfect square? No. Does 3 divide into 36 though? Yep. Make sure you don't lose that radical at square root of 12. Once again, 12 isn't prime, so I'm going to break that down. 4 times 3, and then there's my pair of factors. That pair of factors comes out as a single 2, and then this 3 doesn't have anything to pair up with, so it has to stay under the radical. 2 square roots of 3. Am I right, guys? Okay, I had some looks and I was afraid I did something wrong. Is 7 a perfect square? No. Does 7 divide into 35 though? Yes, so we're going to call this square root of 5. 5 is prime, and done. Ladies and gentlemen, we said there were 3 methods, correct? So we're ready to move on to method number 3. I saved the best for last. All right. So ladies and gentlemen, we're going to end up asking those same questions and still be violating our rules. So we've got to figure out what are we going to do to make sure that we don't have a fraction under the radical and that we don't have a radical in the denominator. So I'm going to start off by asking that first question. Is 7 a perfect square? No. Does 7 divide into 5? No. So I still have a fraction underneath my radical. I can't have that. So you're going to take that fraction and split it up into square root of 5 over square root of 7. We're going to make 2 separate radicals. Because the square root of 7, or I'm sorry, the square root of 5 up in the numerator is legit. It's good. It can stay there. I just need to focus on that square root of 7 in the denominator. I need to get rid of that. So when we need to get rid of it, we're going to multiply the numerator and the denominator by whatever is in that denominator. Because when I multiply the denominator by itself, we're going to create something that works well with this chapter. So I'm going to multiply the numerator by square root of 7. I'm going to multiply the denominator by square root of 7. You're multiplying it by itself. It's 7 over 7. When we have the same thing in both the numerator and the denominator, it's just the number 1, guys. So you're not changing the value of that fraction. You're simply changing the numbers in that fraction. So if we think back to yesterday, I'm going to multiply those 2 radical numbers together. This is going to give me square root of 35. Once again, back to yesterday, I can do radical times radical, and now this is going to give me square root of 49. Which, when I'm dealing with square roots, is 49 a pretty nice number to have? Yeah, because what's the square root of 49? 7. So ladies and gentlemen, I got rid of my fraction, and by multiplying by the square root of 7, I just got rid of the radical in the denominator. So now this looks like one of those problems in method number 1. I need to take the square root of 35. I need to check and see, does it break down? When I look at square root of 35, it breaks down into just 5 times 7, 2 prime numbers. So I know that that's not going to simplify. So my final answer is square root of 35 over 7. You cannot do any more division with that problem, guys, because 35 is a radical, 7 is not. So I cannot take a radical and divide it by a non-radical number. So this is our final answer. Like I said, I saved the best for last. It is the hardest, that's why I saved it for last. So go through those 3 questions. Is 2 a perfect square? No. Does 2 divide into 3? No. So you're stuck with method number 3. You've got to get rid of this square root of 2, so you're going to multiply by square root of 2 over square root of 2. You've got to multiply by the same thing in both the numerator and denominator because that's just the number 1. My numerator becomes square root of 6. My denominator is square root of 4, and voila, we have a perfect square. Square root of 4 is 2. Square root of 6, is that going to break down?
Nope.
Nope. So it's square root of 6 over the number 2. Wow. It is more difficult. All right, ladies and gentlemen, 2 on your own. Yeah. On your own, so let's get them done. Do they have one? Ladies and gentlemen, let's put our pencils down and let's check your letter E. Because if your E is not right, there's probably a chance you're making a similar mistake in F. So 5 was not a perfect square, and 5 did not divide into 6. So I have to multiply by that square root of 5 over square root of 5. Square root of 30 over square root of 25. Now we have a perfect square, so we have 5 in our denominator. So there's no fraction under the radical, and no radical in denominator. And 30, we've seen that a couple of times already today. 30 does not simplify down. It has 3 prime factors, and so we have square root of 30 over 5. You have to leave it here. I cannot divide 5 into 30 because this is a radical and this is a non-radical. How do you do on E, guys? All right, keep going with F. Hey guys, I'm recording this again, so let's bring it down just a little bit. All right, ladies and gentlemen, eyes up front. Anyone match my final answer of square root of 6 over 4? How many people matched my green answer, though, of 2 square roots of 6 over 8? Nice. Why did I go from green to red then? Why would I not stop there and match you guys? Why did the teacher go one step farther? At your table, ladies and gentlemen, figure out how I went from green to red and why I didn't stop there. At your table, figure out why is the teacher so smart?
She went to college?
Yeah. I don't know, there's a lot of people who go to college, right? All right, Ramadeep, why did I go from green to red? 8 can be divided by 2. Grab your calculator, do 2 divided by 8, and turn it into a fraction. It's going to give you the fraction 1/4. You can put the 1 here, guys, or simply know 2 divides into both of those. And that 8 divided by 2 gives you that 4. You're going to see a couple of these on your homework tonight, so I just wanted to make sure you guys saw one in your notes. All right, let's